Hey guys, welcome back to OIC Chris, where it's never too late to have an OIC moment. I just want to remind you guys about the 250 subscriber goal that I've set. If we do reach it, then I'll do those live Q&A sessions before your June exams. In today's video, I'll be covering question 3 of the physics May-June 2021 past paper, so enjoy the video. Okay, let's have a look at question 3. Okay, so question 3 is a vertical projectile question. Okay, so it says a ball of mass 0.06 kilograms is thrown vertically upwards from the balcony of a building 3 meters above the ground. The ball reaches a maximum height h above the ground as shown in the diagram below. Okay, so if you have a look at the picture there, they've indicated everything. So in 3.1 it says name the force acting on the ball while the ball is in free fall. Okay, so free fall is when the only thing that's acting on you is your gravitational force. Okay, then if we look moving to 3.2, okay, they've now given us graphs. It says the velocity time graph below represents the motion of the ball from the instant it is thrown up until it hits the ground. Okay, so they've given us the graph there. You can see that the slope of the graph is a negative as it's moving down, and then they've given us 2 shaded areas there. Okay. So it says 3.2 says write down the acceleration of the ball at time equals to 1.02 seconds. Okay, so looking at the graph there, okay, when we reach the time of 1.02 seconds, our velocity is 0. Okay, we're on the x-axis. Okay, which means we've reached a turning point. Okay, so if my velocity is 0, I've reached a turning point for the ball, which means my acceleration is going to be its maximum. So therefore the acceleration is going to be, so when v equals to 0, it's a turning point. Okay, once we have a turning point, then acceleration equals max. Okay, and the acceleration on the ball in this case is gravity, so h is going to equal to 9.8 meters per second squared, and that's going to be down. Okay, so you can either write down or you can put the negative in front, whichever suits you best. Okay, now for 3.3 it says consider the area A1 and A2 shown in the graph above. Write down the numerical value represented by the difference in A1 and A2. Okay, now they haven't given us any values on the y-axis, and not really given us any other value on the x-axis. But what you need to notice here is that the area under the graph there, so area, first of all we're dealing with the triangle, and we know that that is half my base times my height. Okay, and I'm just going to ignore the half for now because I'm just going to be dealing with the SI units just to show you how we get to the answer. So the base is measured in time, and the height is in velocity. Okay, which means we have seconds times meters per second, which means that second and that second is going to cancel out, which means I'm just left with meters, which is equal to displacement. Okay, so A1 is going to look at the area or the displacement from the balcony. Okay, looking at the building from the balcony to its maximum height. Okay, and then A2 is going to look from the balcony to the ground. So if we take the change in displacement from the ball in its total movement, remember displacement is just from where we start, the shortest path from where we start to where we end, which is on the ground, and that is a distance of 3 meters. Okay, so in this case 3.3's answer is just going to be 3 meters. Okay, now let's have a look at 3.4. This is where our calculations start. So it says calculate the speed at which the ball is thrown upwards. Okay, so we have the time it takes to reach maximum height. Okay, so 3.4.1. okay, so h max time is going to be 1.02 seconds. Okay, so we can use then the following formula. Okay, so we can use v final equals v initial plus a delta t. Okay, Now note that my final velocity is going to be 0 when we reach maximum height. Okay, so up there v final equals 0. Okay, and we want v initial. So it's going to be 0 equals to v initial. Now my acceleration is going to be negative 9.8 meters per second, and my time is 1.02 seconds. Okay, so when you take this across, it becomes negative. We sort out the negative, so v initial is then going to be 9.996 meters per second, but we can round that up to 10 meters per second. Okay, now looking at 3.4.2, okay, it says the height of h, so the height above the ground that the ball will reach. Okay, so 3.4.2. okay, remember they're talking about the whole height, so we want h, which is this over here. Okay, and remember this is already a distance of 3 meters. Okay, so we need to work out this distance and then add the 3 meters. So let's see how we're going to do that. We can use the following formula. So remember, we're dealing in the y-axis. Okay, we're not dealing with x. Our displacement is in the y-axis because it's vertical. So it's delta y equals to v initial, change in time, plus a half my acceleration, change in time squared. Okay, now we have v initial, we've just worked that out, so that's going to be, I'm going to use 10 meters per second. My time is given, okay, that's 1.02 to get from the balcony to the maximum height, 1.02 seconds, half my acceleration, which is 9.8 meters per second. Okay, and then my time again, which is 1.02 seconds squared. Okay, if you plug that into your calculator, remember your acceleration is negative. Don't forget your negative here, otherwise you're going to get an insane height over here. That's going to be 5.1 meters. Okay, but we're not done. They want the entire of h, so we want the whole height here, h. So now we say that h equals to 5.1 meters plus the 3 meters, and that's going to give you 8.1 meters. Okay, now looking at the last question over there for 3.5, it says after hitting the ground, the ball bounces vertically upwards and reaches a new height after 1.1 seconds. Calculate the work done by the ground on the ball while the ball is in contact with the ground. Okay, so remember, when a ball hits the ground, okay, it loses energy. Okay, so what's happening is here it's coming down, it's hitting the ground, and it's going back up, and it's reaching a new height over here. Okay, I'm going to call that big H after 1.1 seconds. Okay, so in order to calculate the work here, remember work the net work done is going to be the change in my kinetic energy, or any energy actually. Okay, I just want to clarify that work is the change in any form of energy. Okay, in this case it's kinetic energy because we're looking at a moving object. Okay, so I need mass, which is given to us. The ball mass is 0.06 kilograms. Okay, remember kinetic energy is a half mass times velocity squared, but I need the change in velocity. So when the ball comes down, it's going to hit the ground with a certain velocity, and then it's going to leave the ground after it's lost energy over here. So I need this velocity, and I need the velocity that it leaves the ground with. So I'm going to work out the velocity that it leaves the ground with to reach the maximum height. So we have the time over here. We know that at maximum height, v final equals 0. So v final equals v initial plus a delta t. Okay, we can just use this formula again. So that's going to be 0 equals v initial plus negative 9.8 meters per second. Okay, why? Because we're moving up, gravity is acting down, and that is 1.1 seconds. Okay, so if we work out all the maths over here, v initial is then going to give you a velocity of 10.78 meters per second. Okay, that's what it leaves the ground with. Now I need to find the velocity at which it hits the ground with. Okay, and for that I have my displacement and I have my initial velocity as calculated above. Okay, so I'm going to use the following formula. V final squared equals to V initial squared plus 2A delta y, because we're dealing in the y-axis, okay, so not delta x. So V final is what I'm going to hit the ground with. My initial speed was 10 meters per second, okay, because that's what it left the balcony with, okay. Then my gravity, okay, or my acceleration, sorry, is negative 9.8, and my total displacement between the balcony and the ground was minus 3 meters. Okay, so it's negative because now we're taking the displacement over here. If we take this as our reference point, then it's minus 3 meters below our reference point. Okay, and if you work out all the maths over here, let me just check. Okay, that's just minus 3 meters. You'll get a V final after you've square rooted everything is then going to equal to 12.6 meters per second. Okay, but now remember my kinetic energy is the change in kinetic energy gives me work. So I'm then going to have work net equals the change in kinetic energy. So it's a half mv final squared minus a half m V initial squared. It's always V final minus V initial. Okay, which is then I can take out the half and m as a common factor. So that's just V final squared minus V initial squared. Okay, and then that's going to be, my mass is 0.06. Okay, final was what it left the ground with, so 10.78 minus 12.6. Both of those are squared. Okay, and if you plug that into your calculator, you should get a value of negative 1.28 joules. Okay, now remember for work or energy, the negative indicates the loss of energy and not direction. Okay, and that's how we go about doing this question. Hey guys, if you did enjoy today's video, then please leave a thumbs up on the video. If you have any questions regarding question 3, then leave them in the comment section down below. I'll get back to them as soon as I can. Just a reminder about the 250 subscriber goal. And thank you very much for watching, and remember, it's never too late to have an OIC moment.